I'm Shiv, the Chief Operating Officer here at Switch, and today we're going to show you our new space, which we're super excited about. There's so much more room to do all of the really cool things that we're doing at the moment, which we're going to show you. One of them is the cruiser back here. We're going to go test that at the Dyno today for Echion so they can get some really great data. And then Mike is going to go through some of our other really awesome projects that we're doing. Check out our videos. We're really showcasing the work that we're doing here. We're really proud of it, so make sure that you like and subscribe so you can continue seeing all the great things that we're doing.
Welcome. New office. Let's show you around. Alright, so we got a new place. It is ginormous. Massive workshop. The Land Cruiser looks tiny in the corner. We've really upgraded the space. And what have we done? We've filled it with batteries. So batteries, Land Cruiser, full of batteries.
One of the really fun things about this particular site is that it actually used to be a Toyota service centre 5 or 6 years ago, and having a Toyota Land Cruiser in here with the potential for us to be installing these systems at scale back in the spot that has a long history with Toyota certainly is a little bit poetic. Certainly a fun fact and something that we're excited about, looking at that possibility of filling this workshop floor back with vehicle lifts and being able to, do some of this work at scale.
So Land Cruiser is ready to go. We'll reverse this out of here in the next hour, and then that will be sent to a dyno run today. All buttoned up, finished as a project car will probably ever be.
Charging up the battery just a little bit, so we've got enough in it for a few runs. We're gonna do some baseline testing. Start off by checking out doing a diesel only run. Do 3 sweeps in diesel only mode, 0 to 100 Ks. See how she performs. Then we're going to switch over to hybrid mode. Repeat the exact same 3 sweeps, go 0 to 100. See what differences we have between diesel and hybrid, and then finish it off by doing the same thing in electric only mode. And that should give us 3 profiles of where the car starts off at. Then we're going to do some high power testing, try and load up the car enough in electric only mode to see if we can maintain a 10-seat discharge on the batteries and see how they perform under that sort of load, which would be about 400 amps coming out of the sub packs. Should be able to do that for about 90 seconds or so before the inverter starts to limit that down.
Like Echion has made these prototype cells. This was the first batch of cells that are actually installed in something, and so until now they haven't had a whole lot of data showing whether the cells actually have the same or the right characteristics of charge and discharge, whether they produce the power they're meant to and can take the regen they're meant to and only get as hot as they're meant to. So we're trying to get some data for them to prove that this first batch was made and operates as intended. I think we're going to go back at it. The next set of tests I think is the hybrid mode, so we'll use the electric motor to help spin up the wheels. We'll be able to compare that to the diesel only mode.
So the team at Switch this time have tested the Land Cruiser on it's called a dyno rig. It's kind of like a big treadmill for cars, so it allows us to test in an environment which we have control over exactly what's going on. We can see exactly how the vehicle performs in different types of conditions. So we've got access to same signals as last time, which is around 5,000 different signals coming from the vehicle. We can see them driving the car to the test center. We've got roughly an hour's worth of testing on the dyno rig. And then driving away. You can see that it's going through swapping between different driving modes. So we've got hybrid mode coming on halfway through, going off. This is to allow us to test between diesel mode and hybrid mode and really kind of compare the efficiency, see exactly what the battery pack is bringing to the vehicle. Diagram from the team at Switch. Here we can see they've labeled that they've done a diesel test, a hybrid regen test, and then another diesel plus regen test. These are really interesting tests because basically what the car's doing is kind of ramping up to full speed. We're going to try and see how much fuel did it take to reach that peak maximum power. Here we have direct access to all of the variables that we have in the database. We can get directly in Python and do all the analysis we want. So here we're taking the data coming directly from the engine, and we're able to calculate exactly the amount of fuel used. So we're using a combination of a signal that gives us the volume injected each engine cycle and the frequency of the engine in RPM. In hybrid mode, it's used around 48% less fuel. And that's essentially because the battery pack is supplying so much additional power to what you would normally get in a vehicle. Because of the material properties of XNO, you're able to fit a lot more energy into a smaller space. Compared to an alternative chemistry, you need a much bigger battery size to achieve this same level of fuel savings. Energy efficiency. Essentially what we're talking about is how, for a given amount of energy that you put into the vehicle, how much of that is actually being used to charge the battery, as opposed to being wasted as heat. But essentially, the idea is we can use the half an hour of testing that it was doing on the dyno rig, where it was being charged at a relatively high regen rate, and compare that to the performance of the battery when it was being charged at a slower rate a couple of weeks ago. Even with this prototype, our energy efficiency is really good. It's above 90%. And we have a reference point for a Tesla model from 2014. And even at double the rate that the Tesla was tested at, we're still at a higher energy efficiency, around 93%. Yeah, and it's been really exciting for us here at Echion to actually see data from our cells in real world conditions. In a couple of weeks, the car's going to be free to roam the roads. And so we're hoping to start getting a lot more data coming through.
So obviously last year, the Land Cruiser was the overwhelming majority of the work that we were doing. What was also happening in the background, we're working on a client project in the rail sector, and also for the last 3 years, we've been developing a hybrid retrofit package for a 150-ton dump truck. And in recent months, that project has escalated to the point that we have a few really enabling partnerships. We're physically modifying a brand new 150-ton Caterpillar 785. The relationship with Echion continues. We're building a large format industrial battery pack using their XNO cell chemistry. That battery pack design we're commercializing, selling to a handful of third parties. Our hybrid dump truck is using that battery pack. So, you know, the relationship, the journey with Echion and Dyno chemistry continues. You know, from what we've seen with the cruiser, we're confident that it's the right chemistry to put into the dump truck, and yeah, pumped about sharing that dump truck journey with you.
If you find this interesting and you want to follow this journey, then please like and subscribe. There will be plenty more.